All right, everyone, welcome to EE360D, the Signals and Systems discussion portion of the class. So, my name is David Santiago. I'll be your instructor, your grader for all your computer assignments, and also the grader for your written assignments too, for EE360 with Dr. Stubers. So, um, this quick Zoom meeting is just to get to know everyone, say hello, and just to say, how's everyone doing? How's everyone's first week back at campus? Fun? No.
Awful.
Perfect. uh, who's already pulled an all-nighter? No one. Cool. Perfect. So I'm assuming this is probably everyone that will be here. As you can see, I just pulled out my little window. So let's see what I have on um, our discussion stuff. So, welcome to EE360. In this class, you'll be utilizing MATLAB or similar programs such as Octave to solve problems that will be difficult to perform via hand calc. So, the outcomes of this discussion portion is that you'd be able to use MATLAB as a practical tool for solving problems. Also, learning the differences between analog and digital systems in MATLAB. So, you would be able to differentiate between using continuous time functions or discrete time functions in MATLAB. So that's a big difference for all those big DSP people slash CMOS people. Use MATLAB to aid with the EE360 lecture theory provided by Dr. Stubers. So there's like little things like convolution or your linear time invariant systems that you'll probably be going over, but don't worry too much. And to apply to higher level EE classes such as, power, electromagnetics, or even control system theory. Research is what I do. As you can see, I'm in the Baker lab. Not that bad. It's pretty cool. We get bottles of not alcohol and plants and fancy, crazy research project circuits, but I can't pull that because it's heavy. But point is, you can use in research and in the practical engineering field. So something I use MATLAB for. Okay, one thing I want to let everyone know. For now, if you haven't used MATLAB at all, if you haven't experienced MATLAB in your life, it's okay. Don't worry. I will help you. Make sure you learn MATLAB and you'll be a master at it, and you can all sing Kumbaya and make sure everyone feels good. So we will just look at the basics of MATLAB and just have fun with it. So has everyone downloaded MATLAB or Octave or any other similar programs? No? Cool. So, if you do have it handy, let's see what I said in the announcement today. My little guide today. Oh, that's that. Welcome to the E360 online class. If this will be an online class only, so that's the world we live in Coronaville. So we will try to meet Fridays at 5:30, either via Zoom or WebEx. Ming Zhu has provided me with WebEx, but I kind of don't like it, so I still have it though. But I prefer Zoom because it's easy and anyone can easily log in. If you haven't used MATLAB, don't worry. We'll teach you to use MATLAB so that you can be prepared for your upper level classes. I'm okay with collaborations on the homework. I used to be an undergrad. Well, I'm a grad student this semester. I graduated last semester, so I'm okay with collaborations. But please do your own work. I've edited the assignments to make sure you are able to solve them and get a cool desired output. I'm not grading for correct numeral values. I'm just gonna grade based on if you understood what the homework was asking you for. So I'll be very fair. I'm not looking for exact answers. I'm looking for, did you know what the purpose of the assignment was? And have fun. Just if you have any questions, you can ask me, talk to me, or email, or ask them. There's a discussion group page on the page that we have here. I made a new discussion right here. So have fun with that. So, are there any other questions before we start looking at some cool stuff? Or let's pull out this bad boy right here. Created a little syllabus. Oh yeah, there we go. So this right here is the EE360D Signals and Systems Discussion. Oh, by the way, I'm gonna pull this. Does this bother anyone? Oh, cool. So, I made a little syllabus. This is based on Dr. Stubert's syllabus. So EE360, this is gonna be remote. You already know this. Instructor, this is my email if you want to email me or talk to me or anything. My office hours will be at Tuesday to Thursday, 11 a.m. to 2 p.m. Forgot to put, oh, there it is, the office. It's going to be in the Baker office, so email me if you want to meet up with me or have any questions or comments. Textbooks, lectures, that's Dr. Stuber's lectures. Computer homework will be assigned regularly and will be collected by a Canvas, usually before the exams. So the first homework assignment's already due. It's going to be due on Labor Day at midnight. So what Dr. Stuber told me is to try to make sure everything is like computer homework and his written homework is just due before the exam. So 2 weeks, probably I'll make assignments due 2 weeks. However, if you guys have any big exams or there's something crazy going on, I'm very flexible. If you email me and let me know what's going on, I prefer communication than just not replying or telling me what's going on. I will try to be as open as I can, but if you don't tell me anything, I'll just lock the assignment. So make sure you just communicate. Homework. Let's see, I already talked about that. We will use MATLAB or Octave. If you don't have the money for MATLAB, there's a free software. It's Octave. It's similar, but I think it's improved over the years, so you can be happy to use it. It's a freebie, so, but there's some other stuff you gotta control in there, but be my guest to use that. We will try to do quizzes. They won't be a huge portion of your grade. They'll probably be very minimal, but these quizzes will just be mental checkers to make sure you know what's going on from the assignments, make sure you know what you're doing. There'll be quick questions, and this is my way of doing attendance, so you don't have to come to these Friday discussions, but the quizzes will probably be around this time. They'll be very simple, very easy. There's no need to like collab with friends. If you can do it, then you're fine. You're ready for the field. You're ready to go do whatever stuff your hiring managers or bosses or professors ask you for. So I'll be assigning quick quizzes, just like Dr. Baker style, so don't worry, you'll be fine. And any type of cheating is punishable by an F. I don't think so we're going to have that kind of problem. If you do cheat, well, you're just cheating yourself out of using MATLAB, which will hurt in the long run. So do collaborate, but try to do your own work. So don't worry too much. So course materials for this course, we'll have 6 assignments. Once we're done with these 6 assignments, this class is over. So we'll probably be done in probably 12 weeks. So 12 or 6 weeks, depending on how fast. So the faster we finish these assignments, faster we're done. So if you guys do want to finish this week, every week, we can finish everything in probably a month. But if you guys want to take it slow, ask me, but I'll try to talk to Dr. Stubert. So let me know what you guys think, and Dr. Stubert will be happy to let me know whatever. Let's see. First assignment's going to be just generating signals. It's a really crazy introduction, just basics to MATLAB, how to use MATLAB. And then I'll try to make a video for that. Make sure I go not too in-depth to give you answers, but give you the tools to finish the assignment, to make sure you know what's going on, how to call a function, how to do this, how to declare variables, time, maybe even graphing or present your work. That's one thing I'll have to discuss later too. And difference equations, convolution, you'll probably cover this all in 360 with Dr. Stuber, probably in the further weeks that come by. And course outcomes, same thing as Dr. Stever's syllabus. So that was the syllabus. Is there any other questions before I go over our little quick homework? Maybe just skim it through a little bit. No. Okay, perfect. So right here we have MATLAB. So if you want to go open that, I'll just walk you guys through the assignment. So if you have MATLAB installed right now, you can do this with me, or will be the tutorial for our live discussion. And I am recording in the background, so I would see if I can, hopefully it's working. I'll try to post this online, so if anyone wants to view it later, we can. And oh yeah, this is all my research stuff. That really helps out, but point is, you'll get to that sometimes. Perfect. So this is usually what you'll probably see in MATLAB. Well, you'll have a script. To open a new script, all you got to do is go to this new plus. You can either press the plus sign, or you can press new, make a new script, and boom, you have a new script. Let's use script 2. And the first thing we'll do is give ourselves a happy title so that it's easy to print out. So EE360 computer assignment 1. Yeah, can everyone see that font? Is everyone good with that font? Or all right, perfect. So let's go over the first things that are going to happen. Maybe I'll move this somewhere. Actually, yeah, here, perfect. So in MATLAB, signals are represented by column vectors or as columns and matrices, and some basic elements in the front. So short, simple signals can be entered into MATLAB by typing a list. So what this is basically saying is, if we go right here to our command window, this is where all our stuff can be done. So let's say we do, for example, you want to generate a matrix. You can generate a matrix by typing this in, and I'll show you that right now. So capital A is equal to this, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And we can press enter, and this is what you'll have. And one thing I'll tell you, MATLAB, treat it right now as a big fat calculator, just a big fancy calculator. It's not going to be a crazy programming language where you need to know C++ or, well, just a little bit, but it's not a crazy programming language. But by the end of this semester, you'll wish it was a real dedicated programming language. As you can hear, Python users kind of look down on this or something or whatever. But yes, MATLAB is a great language in my opinion. So now you have this generated matrix. Now, where is this matrix, you say? Aha, we have this thing called the workspace. The workspace right here is where everything's kept. And you can see that in another window right here. And some of you may be asking, oh, wow, this looks like Excel. And you're right, this is Excel, kind of in a nutshell. So one thing I want to say is MATLAB actually stands for Matrix Laboratory, so it's all matrix oriented. So here's your little matrix that you can do. All your numbers are stored here, and you can do whatever you want. They're in their little boxes. Make sure everything is organized. You can make variables or do whatever you want. So now that we've created our first matrix, I don't know if anyone's following along. Let's go to, let's make this one right here. So because I'm a little lazy, let's copy, paste. Now you see these assignments were personally made so that you can copy and paste them. And let's do it. There we go. So what does this mean right here? So we have 1, 2i, 2 plus 2 times j, and 2 plus 2. So as you can see, column 1, this is column 1, column 2, and then column 3 and column 4. But that looks a little complicated. We can see this by going to our workspace. The workspace is your friend, don't forget it. And you can see all your numbers organized into little boxes. You can double click on them to see them pop up. Lots of digits. So the workspace is going to be your friend. Make sure you organize and keep everything in contact right there. So I know some of you guys are yawning in the back, but if you are, that's good. That means you know what's going on. And you'll probably wonder why we have this little tick mark right here. So in reality, this is this little tick mark. I'll just move this camera there. Is for example, if the built-in functions, these are two functions, are placed after a vector or matrix, MATLAB performs a transpose or a complex conjugate transpose operation. So in fancy terms, in simple practical terms, it just basically flips a matrix. It just flips a matrix, or it flips and conjugates it. So I'll show you a quick example. So I'll put my camera back here. Suppose we did the following. I will write the following script. Let's do x is equal to there you go. Don't have to type that again. So we have the given circuit. We have the given matrix right here. So you're saying, hey, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. What if I want 1, 2, 3, 4, 5, 6 going down, going vertical? So that's easy, and all you can do is, let's do x, and you can create any variable, by the way. So it doesn't have to be x. It could be dog or whatever letter comes to your head. Emojis could be used as variables. That's where I would go crazy. But point is, you can label any variable. So let's call it x transpose, which will equal x, and I will put dot, a little tick right there. I think that's called something. I forget the names, but point is, this little tick, this will do the following. Aha! See, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now your matrix is flipped. Now everyone's saying, what's with the period? So let's do the following, where we create a vector y, which is equal to x, because I'm lazy. And now we just copied this. Instead of copying this as shown like this, I can just put x equals here, y equals x, and you get your result. But what I was going to do was probably, okay, we'll do that because we're not necessarily copying the whole thing. Let's put this as times j. All right, so we have now the following. Now you see, once you get into the complex domain, everything gets crazy, and you're like, oh my god, there's so many decimals. But as you can see, we have an imaginary number here. So what I'm going to try and do is we're going to do yt1 is equal to y, this, just a tick mark. So let's see what that does. And as you can see, if no one can see that, it's okay, don't worry. I will pull this guy out too. Here's our y, and here's our imaginary number. If you wanted to flip the whole matrix, it's going to flip the... there's two ways of flipping it. You can either flip every number and column, or you can do a complex conjugate, which you can use in your upper level maths. This is our original variable, and if we do one tick mark, everything gets complex conjugated. So this guy gets negative, as you can see, a little negative sign. However, if you do yt2 is y dot tick, or whatever that thing is, as you can see, let's open this, we have a positive. So generally you should just use this if you want to control all the raw data you see in any variable. But if you do know what you want, as in you want a complex conjugate, you can be my guest and use this version. So that's very handy. Don't forget it. Oh, and by the way, you're probably asking, oh, look, it's always putting my result here. So what if I do the following? Let's put some semicolons, and watch this. Oh, wait, hold up. Let's do this. As you can see, the only thing that's being outputted is x. As you can see, the semicolon, if you've already read the assignment, the semicolon is in charge of just suppressing the output. So suppose this x is going to say, oh, we're going to store a value. And this will say its value, whatever it's called, unless you press a semicolon and boom, nothing happens, even though you saw nothing. But let's just clear the command window. It's always nice to do that. It will tell you this, but I always press OK. If I press, there's two ways of running. You can either run section, which I like doing, or you can run the whole program. And we can do this. So suppose I go to my 360D and let's create MATLAB and let's title this comp EE360 comp homework 1. Boom. So this is going to happen usually when you start up MATLAB. So one thing I'm going to tell everyone, make sure you try to keep your directories clean. Make sure you know where you're storing your MATLAB, because this can cause a problem. I think a student in the previous semester in my class, when I was taking this, lost his MATLAB assignment. He was like, I can't find it. And you can just check for your path. Make sure you can see your path right here. But change your folder to keep your directories clean, and you can see where your directories are. So that's really good. And as you can see, the program run. You didn't see it, but let's prove it. So if you press run again, and when you press run, you actually get this. So I will suppress it and press run, and the program runs. So now that we have that in mind, let's go to here, and I'll move that away. Most of this is self-explanatory, so I will let you all read through that. And let's get to problem number 1. So if anyone's writing this down or wants to look at it. So we will generate the following signals for -5, greater than or equal to n, which is greater than or equal to 5, by typing an explicit list of elements. So what I'm looking for is, can you type? So we will do the following. So you will notice I have a writing style. Let's do this. Exercise 1. Generating signals. There we go. I'll make another video on how to publish and make really pretty graphs, and make sure that when you submit a plot, it looks nice for me to grade, or like when you have to review it. So the double % signs makes a new section, and I'll show you. Actually, I'll show you a quick tutorial. So x equals to 1 and y is equal to 2 and z is equal to 3. So if I press run section or control enter, which is my favorite command, just control enter, you'll love that command all the time. Run section, this is the only thing it runs. So you have that power. What if I want to run this? There you go, and this. So now you have all your outputs, but let's say you want to play all of them at the same time. I press run, boom. As you can see, everything played. And that's our, if you can see right here, EE360 comp 1, X, Y, Z. So that's how you create sections. So that's very handy for when you want to place a figure after, or a figure, or a plot, or anything, a picture after your homework solution. So I'll do maybe a couple of them. So let's do the first one. So have you guys gone over the Dirac delta, the Kronecker delta? Yeses or nos? Hello?
Technically, yeah. It was covered in the Strong's outline.
So you've already experienced the Dirac deltas. Does anyone want to tell me what it does? or what's the definition of a direct delta, which could be on the midterm or the exam that's coming up. We don't know. Oh man. Well,
I think it just goes to infinity at one point. It spikes.
yes, it's a spike. So there's two types of deltas, direct delta. So there's the direct delta, which is the analog version of like a spike. So it's really small and has a huge spike, but the area is 1 for some reason, and that goes crazy. And the other definition, and I'm telling you now, Dr. Stuber will dock you points. And he's already had arguments, but these are true definitions. So there's the direct delta, and then there's the Kronecker delta. The Kronecker delta is basically the digital version of the direct delta. So at 0, time equal, or at n equals 0, so you have n equals 0, 1, or minus 1. At this point, it's just up, just 1. So remember those two differences. I don't know if those will be on the quizzes or not. I don't know, or on the exams. So do keep that in mind. They're very different. Kronecker is digital, and direct delta is analog. So don't forget that. Write that down. And don't forget, write down what a function is. Shh. What's the definition of a function? I don't know. Oh, oops. That's good information to keep in handy. And you probably won't cover convolution, but that's another word too. So let's see. Linear time invariant systems. So a Kronecker delta, before I explain this is all digital. Everything is going to be in columns. You know, we have arrays, as you can see. Let me click on this. We have boxes, so we're not going to have a continuous function. We're not going to have a continuous sine wave function, but we can make it look like we can. But point is, everything is going to be in boxes. So for the following presentation, it's going to all be digital. So the Kronecker delta is going to be 1 at 0. So if you want to brute force this one, so there's many ways you can do it. You can be my guest on what you want to do. Make your life easy. So let's call it cron or whatever, delta or something, or I'll just call it delta. Delta, and this is what I mean by explicitly doing this, is we're going to do 0, 0, 3, 4, 5. Let's do this. So 5. There's going to be 11 signals. So that means 1, 2, 3, 4, 5. This might be 1. 1, 2, 3, 4, 5. Is that it? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. This is it. And let's do n is equal to minus 5 colon 5. So I forgot to go over this guy. So this colon right here just gives you a list of numbers. So watch this. Okay. So if you don't believe me, let's run section. And as you can see, it creates 11 numbers. And it tells you right here, 2. This is also a good thing to look out for. So if you want to know how much elements, instead of going through, that's an example. Oh, I'm going to count 1, 2, 3, 4. Instead of doing that, you can always look at these little numbers right here, and you can get the size of the array pronto. So this one right here has 11 numbers. Keep that in mind. And let's generate this signal. Oh, look, we have 11 numbers. So let's teach you your first function, and that function will be the step function. So the step function, or not step function, the figure function, the figure and the stem functions, as you can see right here. So the figure function is just basically, okay, we are preparing for a figure. What figure do you want me to call? So there's many figures. You've probably seen them, like, you know, your Bodie plots, or you have just a pie chart, or any figure you can think about, any math plot you can think about. figure is something you have to call, or you don't have to call. You have to put before any other like plotting system. So this is for printing purposes. Make sure you do this so you can adopt my standard if you want. So figure 1 just says, okay, actually, if you don't believe me, let's control run section. And as you can see, it popped up right here. So this just says, okay, this is our canvas. What are we going to put on it? So let's put a stem plot. And the stem plot, and remember this too, actually, here's the cool thing about MATLAB. It tells you what you can do. So you can plot just the data if you want to. Let's do that right now. Delta. There we go. And there it is. That is our Kronecker delta. However, if someone told me, no, that's not it, you're correct, because this is not it. As you can see, our time scale is from 1, 2, 3. This should be 0. Why is it not 0? So we're going to try to make it 0, and the stem function can tell us. So right here, we can place our time. So our time, or our sections, or whatever you want to call them, sampling points, it's going to be n. So this just says, okay, we're going to put all our columns in here. Make sure they're the same size, because I'll probably generate that error too. So delta. So this just says, okay, our x-axis is going to be some time. Our y-axis is going to be our data, which should be the format. And watch this. Oh, look at that. There we go. -5. This is 0. You see, now your theory is coming to play. This is all practical usage of MATLAB. So now you can use this for anything you want, like convolution or your ZIRs, or just kidding. But point is, this is all future topics. This direct delta is a very essential thing to know. So this is your solution to number 1. There you go. Want to screenshot that? Oh, don't worry. I'll probably see if I can upload this video. So, hold up. Oh, why did everything go away? Okay, there you go. Oh, let's see. So, suppose I were to mix around a bunch of figures. Could you tell me what this figure is just by looking at it? It's a Kronecker delta, you told me. Yes, it is. However, what happens if you need to look at your notes maybe in the future? So, what is this? Oh, that's a different MATLAB. Oh, don't see that. That's the answers. No, I don't think so. Let's bring out our figure. Actually, let's close that guy. There we go. No. So, one thing that's going to be important in this class is you got to label your plots. I want to see good labels. I want to see what you're doing. This is not just for me. This is for you if you want to look at this in the future. Like, oh, what was this plot about? EE360 still helps me to this day figure out what's going on. So let's give it a title, and I'll put this guy on the sideline. Or actually, I'll put it in real time so you guys don't believe it's magic. All right. So let's give it a title. So the title function just says title of whatever figure is there. So let's do title, and to do a title, it tells you text, target. But to do that, to make a text, we use either these little tick marks, or you can use commas. So I'll use commas if you want. So the Kronecker or the delta function. I don't even know what it was asking for. The unit impulse sequence. There you go. The unit impulse sequence. There we go. And then we end it like that. And you don't have to put a semicolon on this one. I don't think so. It does anything special. But let's run section. And boom, we have the unit impulse. So now you know what it's going on. Well, wait, if you want to get a little fancier, you can also do exercise 1, 1A if you wanted to. Put that there. And you can, in real time, you can change the titles or anything. So that's very nice. So, okay, can anyone tell me what this axis is? No, it's okay. So now let's label the x and y axis. So who knows? Oh, it's going to be called x-axis or x-label. This x-label function just says, okay, we're just going to give it a label. So let's call the x-axis n or something like that. There we go. And y-label, let's give it value or something like that. There you go. And if you don't believe me, let's run. And boom, now you have value and you have n. And there you go. This is the answer to number 1. So did you understand what was going on with this problem? What I'm trying to tell you, there's a couple things. There's 3 things. 1, what's a direct function? Do you know what it is? Oh, the Kronecker delta is 1 at 0 and 0 everything else. So this is literally it. The second thing is you can change the time. You can look at this and you can change it to whatever you want it to. So I'll probably go over that in the future questions. And you can put labels. That's very important. And you have the essentials to become an engineer and do whatever you want and use Excel as your personal calculator if you want. That's number 1. And now let's talk about the unit step sequence. So does anybody know the unit step sequence is? Have you covered it in the Shams book, I'm assuming?
Yeah, it's in the first chapter.
Perfect. So you guys already have experience. So what's the definition of that?
I think it's 0 until at some point it switches to 1.
Yes. And when does it turn to 1?
I think at 0
Yes.
under the delay.
There you go. It turns. So the one thing you got to know is everything before 0, so -1, -2 to -infinity is 0. However, it's like a switch. So at time 0, at this time, we turn on, we become 1, we do whatever we have to do. So that's what the unit step is. So let's brute force that right now. So type in explicit list. Let's do it. So does it bother anyone if I do this? So 0, 0, 1, 2, 3, 4, 5, 6. There we go. Does that bother anyone? No? Oh, what's this? Oh. Let's see if that runs. And it does. You can include commas, and you don't have to include commas. But look at this. You see, there's 1 row and 11 columns. But what happens if you were a crazy guy and you were like this? So there you go. I don't know if this is going to run. Oh, it does. Perfect. As you can see, it's 11 by 1. So now we flipped it, and you can see it looks flipped. But what about if there was a shorter way of doing it? Man, that was a lot of typing. I know, but there's a thing called that. Same thing. And if you don't believe me, let's change it back to our thing, run section. See, created that. Let's add this. Very useful for data collecting and processing. This will be also your friend, so don't forget it. But let's go back to that. So let's go back to it being all vertical. Do we have to instantiate another time? You can, but you'd be wasting space. But if you have a lot of space, be my guest. This is your clean space. You could do n1b is equal to -5 to 5. And if you want to see that, okay, here's another cool function. So if you highlight this and you want to evaluate just this code, just this, you can press F9. And this is also a lifesaver too. And boom, generates a new one. But as you can see, this vector, this matrix, this row of numbers is the same thing as this. You don't have to do this. This is not necessary, but you can have it. So there's that. Now let's go to figure 2. There we go. Stem, N, and unit step. There we go. And who can guess what this is going to look like? And it popped up right here. And there you go. That is the answer to part B. And how do you know? Because at 0 for discrete systems or discrete time, at 0, the unit step becomes a 1, and it goes 1 to all the way to infinity. So that's how you know you got it right. If for some reason, suppose you were like, oh, I'm kind of like, whatever. Let's do, actually, let's keep that. And suppose you did this. Okay, we're going to go from 0 to 10, right? So let's do, or 1 to 10, let's do, oops, is equal to 1 to 10. And let's run this. So I'm going to press F9, or I don't think so, I should. I think that might stop the recording. F9. And as you can see, where is it? Where'd it go? Aha, it didn't pop up its little thing, but you can see that's 10 numbers. But suppose I did this. Oops. And I run this. Run section. Ah, look at that. Our first error. Our first beep of the day. So X must be the same length as Y. So you don't know how much this has like ticked off a whole bunch of engineers. They would go to the TA and they'd be like, oh my gosh, my thing doesn't work. And the first thing is, did you check the sizes of your array? Oh no. Make sure you check your size array, and you can see that by, well, it doesn't say here, but suppose you were to do, I'll probably show you a cool function right here. So you see how we have a whole bunch of zeros, and we have a whole bunch of ones. So if we're going from -5 to 5, we would essentially have 5 zeros and 6 ones for a unit step. So there's 2 ways of doing it. So I'm going to make another function called U. So there's 2 functions, and they're very helpful. They're used for, ANDing or XOR or whatever you want to do, on switches or any type of thing. Anything that can control or even fill up space. Like you want empty space to allocate memory. Allocating memory is good. There's this function called, let's do this. Let's do ones. Ones, we're going to do a 1 row of 11 values. So now you have 11 ones. So this is not a unit step, by the way, but I will make it a unit step. Let's evaluate section. And boom, here's you. You have 11 ones. Easy. But we want zeros, so let's do this. We're going to do zeros. We're going to do from a 1 row of 5 zeros, comma, and we're going to do 1 row of 6 zeros. There you go. And let's run this, F9, or you can run section, whatever you want. F9. And boom. Now we have our unit step. And if you don't believe me, let's change this time to N, which is defined right here. And U, and no U, there you go. And boom, we get the same thing, but do we know? Make sure you title. Okay, the unit step sequence. Unit step sequence. And X label is going to be N, and Y label is going to be value. There we go. And as you can see, we have the solution to problem 1b. So you'll probably see all these. This is all just brute forcing. If you know what's going on, if you know how to make signals, suppose you're like, oh, I want to start at time equals 0 or something equals 0. If you know how to do this, you're set. You're golden. You can pass this class. You can pass even 480 if you want to. There's people still kind of struggling in that class, but the point is, this is your basics, your fundamentals. I would start to get used to how to organize time and how to organize your data. So I will leave the rest to you. And let's see. We'll leave number 2 for you to do. And oh yeah, here's your bonus problem too. This should be fun to do. So Dr. Steve let me add a quick problem. You'll learn more about this throughout the tutorial that he has here. I'll make a video going over the various functions and how to even design your, or how to make your stuff look cool. Actually, if you guys want to look at something, a sneak peek, because I like being fancy. So suppose we have our unit step function. So I want to teach you something advanced. Not too advanced. Suppose I wanted to change the not the title. I wanted to change the color. The color of this. You like blue? Can you see it? Well, if you want to make it thicker, you can do this. So let's call it line width, and let's give it a thickness of 2. I guess default is 1. Oh, what's it saying? Line width. Oh, I forgot comma. There we go. Oh, it didn't go there. Oh, that's the wrong one. There it is. Ooh, pretty, right? Well, what happens if you want to make it bigger? Oh yeah. But do you see these dots? So we're dealing in discrete time. So discrete time is gonna be just these pegs, sticks. So don't be so sneaky and do plots, because that would just make it look like an analog function, which looks cool, but this is not the purpose. If I do see plot, don't use plot. Only use it when it's necessary. All this is going to be stem. If you use plot, I will take points. So, but you'll be fine. Just stem, and boom, there's your answer. But you see these dots right here? They're not really filled. You can actually do stuff on this graph too. See that? It has a hole. Oh, if you click on it, it tells you the value too, and it sticks there. Want to take a quick screenshot? Let's see. I think it's copy filter. I always copy figure. And let's open up a Word document. And suppose I'm gonna do my EE360 submission. So EE360 subs, and then 1, or actually this is question 2, or 1b, and you paste your code because I need to see it, and boom, there you go. It looks pretty fancy, right? Cool. So yes, there's that. But point is, let's fill up these holes. Let's type right here. Filled is the keyword you look for. And let's enter that, and boom, your holes are filled. You want to change the color? I think you can do that right here. Let's do this command. It's common. I'm going to make it a line. It's going to be a straight line that's colored red. And boom, you have a red line. So if you want to make stuff look colorful, you could be my guest. So I think that's it for that part. And this should cover the first 2 essential stuff. And so quick notes on the assignment. You guys have until not this Monday, but the following Monday to finish the assignment. So don't worry too much. But this is a lot. Well, it's not a lot, it's just a lot of tedious, easy stuff. I did change some stuff. For number 4, I would like for everyone to try, or if you're confident, to try to use estimated hand calcs, because I don't know how much experience everyone has with MATLAB, but you don't have to turn this in. I don't think so. I'll make it turn in, but make sure. So suppose your professor said, "Okay, I want you to calculate a cosine from 0 to pi in just 5 points." Oh, easy, right? But what happens if they say 25, or even worse, 100? So the point is, I'm trying to make sure that you think I was gonna actually make you guys do like 11 points, but that'd be too much work. Yes, too much work. So that's when MATLAB comes into play. MATLAB is here to help your like ease work. Instead of doing 51 little things, MATLAB can do it in 1 second. So treat MATLAB as a practical tool, and this can be used in any class: power class, controls class, any even 330 EE330 with Dr. Schill. Oof, it makes you do crazy integrals. If you want to add all those integrals, no, MATLAB. MATLAB will help you. So definitely treat it as your friend. But if you do estimated calculations, so if you know what cosine pi over 5 is, cosine pi over 2 pi over 5, make sure you're right. Like, oh, at time equals 0, this is what it should be. So that's just to verify that you've done it right. But everything else should be the same. Ooh, I made this one too. This one's going to be fun. If you want to see what that looks like, you'll have to generate it on your own. And I made an easy one. This is an easy added problem. So this is probably the only extra. This is the edited part. Oh yeah. If you've done the assignment, there was an error. This originally said 3. This should be 4. So all the generated signals you had here should be here. I'll probably make that an announcement, but due to everyone being here, that's a good announcement. So if you're watching the video, you already know. So that's the assignment, and you've already probably seen this, but we've already seen some imaginary numbers pop into play. So here's our little imaginary thing. So let's do a variation of this problem. So we're gonna kind of do problem 6. So let's call it 6 something, 6a or whatever. And yes, you can put a number in the front of your variable as long as you stick it to an actual text. If you leave a number, you can't save a number into a number. I don't know why people would do that. So 6a. So let's do this. 1 or 1, 2, 3, and then let's do 3i, or 3 times j, I guess. 3 times j, 2 times j, and j. So what's this gonna look like? It's gonna look like a pretty cool ramp function. So it's gonna be like, oh, the amplitudes. In terms of amplitudes, it's gonna look like a little triangle. So is that true? So you can do this figure, and I don't remember, but let's do figure 20 YOLO. And yes, you can name any figure. Just keep your figures in order. Sometimes if you don't, let's suppose if you put figure 2 here and you have another figure 2, you can do that. However, it's going to print out. Be careful with your printouts. That becomes a problem. So make sure you keep your numbers separated. Some people did like 2, 4, 6, 8. I don't know why. Just do 1, 2, 3. But let's do figure 20 because we're all here. Or 200 if you want. STEM. STEM 6a. And this is just a quick plot. If you want to see something like data, like suppose you had data that your professor gave you, this is great to like analyze quickly what happened. So let's run section. And what went on here? Invalid. What's this? 6a. Check for missing multiplication. Oh, it doesn't like J. 1 times J. So yes, it treated this as a variable. So be very careful, as you saw what I did there. Maybe it doesn't like this. A. Something happened, but whatever. Whatever I did, don't. So here's a triangle. Oh, where'd it go? Oh, it's zeroed. What happened? So it only plots the real component of complex data. So just like you can't generate a delay, you can't generate imaginary signals. This MATLAB is by default going to post or plot real signals that you can touch, feel, or sense, or whatever. So suppose you wanted to see it, like if you're going to make a Bode plot or you want to see a circle. So we can always do this. So I wanna see the real function, or not real function, sorry, abs of a. So this is just the absolute value. You can't do this, or you can't put those types of absolute value. That means something completely different. But if you want to see this, I'm too lazy. Let's copy paste. Yes, you can copy paste. And boom. Well, I forgot the tip, but it's okay, whatever. Okay, you guys want to see the tip. Let's add a number here. 4. There you go. Make you happy. Cool, right? Yeah, that doesn't sit with me. Oh, whatever, YOLO. But now you can see it. But if you don't believe me, let's put A again. And look, all the imaginary numbers get suppressed. What happens if you want to see imaginary? So imagine, or whatever, or whatever. Plus C2. You can see the imaginary numbers by doing imag of A. And then let's put C2. Run. And look, all the imaginary numbers, but let's do this. Figure. And we're almost done, everyone. 201. Stem. C3. See, MATLAB is super fun. C3, you can do whatever you want. Real of A. So you can either plot this, or if you don't want MATLAB to bark at you, you use the actual real function so that it doesn't think you're dumb. So if you want to see that, run section, and here it is. The real part, the imaginary part. How did I tell? That's because I know it. But however, if you want to present to your friends, this is why you need to title your stuff. Title imaginary, and there you go, title real. So I know my plots, but you won't, and then vice versa. You know your plots, I don't. So that's definitely good to keep in contact. Real, imaginary, and then figure 202 stem. I wanna see. There we go. What the hell? Oh, rip. There you go. And here's our new plot. So that was our very brief introduction to MATLAB. Are there any other questions or concerns or comments or doubts, like difficulties with how this discussion might go? If anyone thinks it's going to be too much or might have any difficulties, or even doesn't have MATLAB. Because if you don't have MATLAB, we're going to have to figure that out, or you need to get Octave or something like that. Are we good?
I have a question, but it's not related to the discussion.
Okay.
Just for his class, like, how much should we be focusing on his book?
Which book? The Shams book or the actual notes?
The one he wrote.
So I'll be honest with you. If you want to pass this class, just read the notes, but not the first time, the second time. So he might go over the notes in class, and it's dreadful. You kind of get sleepy. Use the videos, read the notes. There's a lot of examples, and there's actually you think the book would be boring, but in reality, a lot of grad students would love to get their hands on that book again because they probably lost it. So keep your notes. It's a really good book. He's still trying to finish publishing. I'm gonna see if I can like help him publish because it's a really good book, and you can actually probably see the book. It's gonna be called this. I don't know, but do focus on the book. On the notes that he hands you out. It's a really good read. There's a lot of stuff, and even it helps in my higher level CMOS classes with Dr. Baker. The notes in my I'm doing his mixed signals class, and that is literally like helping me. Even 360 notes are helping me in a 700 level class, and some of the other grad students are kind of jealous. But it's definitely a good read. All the vocab in there, it's a lot, but you'll see it in the field. You'll see it in grad school. You'll see it by the time you become a senior, your fourth year or fifth year or sixth year, or whatever you call it. It's a lot, but once you learn the lingo, you're an electrical engineer. So definitely good stuff to learn. Written homework. I'm assuming everyone is here, or a majority of the people are here. I'm grading the homework. I'll be grading the written homework. I'm only grading for completeness. As you can see, the Shams outline is. You'll probably look at it and like, hey, wait, the solutions are here. Yes, the solutions are there. Should you use it as a study guide? Maybe, but as long as you complete the homework and do it, please make if the homework assignment, the written homework is due Wednesday. Make it look like it's due Monday. It's a lot of writing. I'm telling you now, lots of people cannot finish it in one day. It's a lot of writing. You'll regret it. So if I were you, try to finish it before Labor Day so you can focus on finishing the computer assignment, or please try to make sure you do stuff on time or a little bit chunk by chunk. It is worth 2% of your grade, but Dr. Stewart has it's his effort checker. So if you did it, he thinks like, oh, he's not lazy. But if you didn't, he'll probably think you're lazy. So it's 2%, but make sure you try to do those notes. It's not the best book. However, it's the resource that we have available. Is there any other questions? Actually, yeah, any other 360 questions or what to expect, or even outside that lecture class question? We good? All right. So I guess if there's no more other questions, this is the first meeting of EE360 discussion. I would like to say thank you all for coming. I'll try to see if I can post this video somewhere online. I'm recording this. I don't know if it's going to work. I'll make an announcement if that happens or it doesn't. So with that, there's chat. Oh, there's a chat. Oh, God. Please upload this. It would be really helpful. Seems pretty straightforward. Thanks. Please post. Oh, God. There's a... Not yet. There's something. Oh, gosh. Yeah, I should be looking at the chat. But yes, thank you for letting me know. Contact me. Talk to me. Let me know. I'm really easy to work with. However, due dates are due dates. So, and the assignment's locked. So, no late assignments. Or maybe I will for like 5 minutes. But anything else? Chat's fine. Nope. And microphones are off. All right. thank you all for coming, and I will be ending the stream right now. Bye bye.